Here we have a problem on integration. That is, we have to aware with this indefinite integral using the specified substitution, that is u equals to square root of x95. Okay, here we substitute a new variable u for this stuff square root of x95. Since we substitute the new variable u for this stuff, we have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du, so that I'll be able to do integration with respect to u. Okay, if I want to get du at the place of dx, what should I do with this u? I have to find derivative. And here u has been defined as a function of x. Since u has been defined as a function of x, we can find derivative on both sides of this equation with respect to x. Before we find derivative on both sides of this equation, we can write this square root as an exponent. Okay, let me do the stuff we have over here. That is u equals to square root of x85. Okay, first let me write this square root as an exponent. When I write the square root as an exponent, it will be 1/2. Okay, now I can start finding derivative on both sides with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. So here, when I do derivative of this stuff, first I have to do derivative for the exponent we have over here using the power rule of derivative. That is, we have to bring this exponent 1/2 in front of the variable part and subtract 1 from the exponent. So far I have completed derivative only for this exponent 1/2 using the power rule of derivative. By chain rule, I have to do further derivative of this base x95. When I find derivative of this x95 with respect to x, I'm just getting 1, because the derivative of this x with respect to x is just 1, and the derivative of the constant -5 is 0. Then we get times 1. Then we get du over dx equals to 1/2 times x -5. When I simplify this 1/2 -1, I'm just getting -1/2, and when I multiply this complete stuff by 1, still I'm getting the same. Okay, let me continue over here. Then we get du over dx equals to since the exponent is negative, we can move this complete stuff to denominator to make this negative exponent as positive. Then I'm getting 1 over 2 times x -5 to the power of 1/2. Now the negative exponent becomes positive because we have moved this term to denominator. Now we can multiply both sides by dx to get rid of the denominator dx over here. Let me do it. Then dx will cancel out. I am getting du equals to 1 over 2 times. Since we have exponent 1/2, it can be written as square root. Then we get 2 times square root of x-5 times dx. Then we have du equals to 1 over 2 times, and for this square root of x95, we can plug in u, because we know that u equals to square root of x95. Then we get 1 over 2u times dx. Okay, now let me multiply both sides by 2u to get of the denominator over here. So 2u times 1 over 2u times dx. So here this 2u will cancel out. Then I'm getting 2u times du equals to dx. Okay, now let me consider this particular stuff in the integration, that is x positive 6. Now in this x positive 6, what I'm going to do is I'm going to subtract 5 from this x, and also to compensate the subtraction of this 5, add 5, and I take this positive 6 as it is. Okay, I have subtracted 5 from x, and to balance that I just added 5, so that it will become 0 pair. Still this is equal to the original stuff x positive 6. Then we get x-5, and we can combine this positive 5 and positive 6, and I'm getting positive 11. Okay, now I take square root for this x-5. Okay, so I've taken square root for this x-5. Okay, to balance taking of square root for this x-5, I just square this, and I'm taking this positive one as it is. Because here the square root and square will cancel, still it is equal to the original stuff x-95. Okay, why I'm doing so? Why should I take a square root, and to balance the square root I'm taking square? So because when I have square root of x-95, I can plug in u for that. So now for this square root of x-95, I can plug in u, then we get u square, because for this one we plug in u, and here we have square positive 11. So for this stuff x positive 6, we get u square positive 11. In our next step, what we can do is in the original integration, for this square root of x-95, we can substitute u, and for this dx, we can substitute 2u times du, and for this x positive 6, we can substitute u square positive 11. Okay, now let me continue on the next page. So here let me write the original integration, that is square root of x-5 over x positive 6 times dx, and for this square root of x-5, we can substitute u, and for this x positive 6, we can plug in u square positive 11, and for this dx, we can plug in 2u times du. Okay, now this is a constant multiplied by the variable part over here. In integration, whenever there is a constant multiplied by the variable part, it can be moved out of the integration. When it moves it out of the integration, I am getting 2 times integral. And also when I multiply this u and u, I am getting u square over u square positive 11 times du equal to 2 times integral. So here what I'm going to do is in numerator, I'm going to add 11 to this u square. So that is then I'm getting u square positive 11. To balance the addition of this 11, I subtract 11. So when I simplify this one, still it is equal to the original stuff u square. In denominator, we have u square positive 11 times du. Okay, now I consider this u square positive 11 as just one term. This is another term. Okay, here we have subtraction of two terms, and the common denominator is u square positive 11. Since u square positive 11 is a common denominator, it can be taken as a denominator separately for this and this. Then I'm getting 2 times integral u square positive 11 over u square positive 11 negative 11 over u square positive 11 times du. Now this u square positive 11, u square positive 11 will cancel out. Then I'm getting, let me continue over here, 2 times integral 1 negative 11 over u square positive 11 du. Okay, now we can keep this constant 2 as it is. We can distribute this integration sign to this one and this one. Then I'm getting 2 times integral 1 du negative integral 11 over u square positive 11 du. Okay, then we have 2 times integral 1 times du is just du, and since it's a constant, we can move it out. When it is moved out, we have a negative 11 times integral. Since this constant is moved out, we'll have 1 in numerator and u square positive, and I can write this 11 as square root of 11. Actually, we don't have square root for this 11, but I'm taking square root. So to balance the square root, I can take square. Then we have du over here. And here we have a question, why do I do this one? That is, here we have 11, I'm taking square root. To balance the square root, I'm taking square root. There is a reason for that, because there is a formula in integration, that is 1 over x square positive a square times dx. Whenever we integrate a function in this form, here variable square and a constant is squared, then the result of this integration is 1 over a times arc tangent x over a positive c. So to get this the stuff we have over here exactly in this form 1 over x square positive a square, I take square root for this 11 and square, because I need a square term over here. But 11 is not a perfect square, that's why I take square root, and to balance the square root I just squared. Now at the place of x square we have u square, at the place of a square we have square root of 11 square. Now to get the result of this integration, we can use a formula. So in this formula, at the place of a we have to write square root of 11, at the place of x we have to write just u. Okay, let me continue over here. So we get 2 times when I integrate this du, I'm just getting u negative 11 times, and the integration to get integration of this one, we can use a formula over here. That is 1 over for a we have square root of 11 times arc tangent for x we have u, and for a we have square root of 11 positive c. Okay, we can do further simplification on the next page. Okay, let me continue. So we have now what we can do is we can distribute this 2 to this u and this stuff as well. And also when I multiply this 11, I mean 11 times 1 over square root of 11, I'm getting 11 over square root of 11. Now let me do it. So we get 2u negative 2 times 11 over square root of 11 times arc tangent of u over square root of 11 positive c. Okay, now what we can do is we can write 2u as it is 2 times. Now we can rationalize the denominator, that is we can get the square root. For that, what we have to do is we have to write this 11 as square root of 11 times square root of 11, because square root of 11 times square root of 11 is equal to 11 divided by square root of 11 times arc tangent u over square root of 11 positive c. So here we can cancel this square root of 11, square root of 11. Then we get 2 times u. Actually, u is a variable taken by us. I mean, it is given in the question for u substitution. So the original stuff we have for u is square root of x negative 5. This is given in the question itself. Now, what we can do is we can plug in this original stuff for square root of x negative 5 for this u over here. then I'm getting 2 times square root of x negative 5, negative 2 times square root of 11 times arc tangent, and here for this you also we can plug in the original stuff, that is square root of x negative 5 over square root of 11 positive c, then we get 2 times square root of x negative 5 negative 2 times square root of 11 times arc tangent. So here we have square root for both numerator and denominator. In a fraction, we have square root for both numerator and denominator. We can take the square root in common. Then we get square root of x negative 5 over 11 positive c. So this is the evaluation for the given indefinite integral.